Welcome to Daily Papers, where we break down the most interesting new research. Today, we're diving into the world of AI safety. You know how when you ask a chatbot like ChatGPT or Llama a dangerous question, it tells you, "I'm sorry, I can't help with that."
Right, it's got these safety guardrails, and the common assumption has always been that this sense of safety is baked deep into the AI's core. The idea was that during its training, it learns this complex, network-wide understanding of what's appropriate, kind of like a company's culture.
Exactly. You'd think it's not just one thing you can point to, but a general vibe that's distributed across its entire massive brain. To stop it from being harmful, you'd have to change its whole philosophy.
But what if it wasn't a whole philosophy? What if it was much, much simpler and maybe a little more fragile?
That's the core question of a new paper from researchers at Apple titled, "A Single Neuron is Sufficient to Bypass Safety Alignment in Large Language Models." And their answer is pretty mind-blowing. They found that this complex safety behavior might hinge on just one single tiny component.
Okay, so before we go on, what exactly is a neuron in an AI model?
Great question. You can think of the AI's brain as a gigantic network of billions of tiny switches or dials. Each one is a neuron, and when the AI is thinking, different combinations of these neurons fire or light up to process information and produce an answer. This paper found that the entire safety system might just be a couple of very important specific neurons.
So it's less like a company-wide culture and more like one single very important security guard standing at the front door.
That is the perfect analogy. The paper suggests there are two distinct systems at play. First, you have what they call refusal neurons. These are the security guards. When a harmful question comes in, like, "How do I make a bomb?" a specific refusal neuron fires up and basically hits the big red "No" button, triggering a polite refusal.
So that's the gatekeeper. What's the second system?
The second system is made of concept neurons. You can think of this as the library that the security guard is protecting. This is where all the knowledge the AI learned from the internet is stored, including the dangerous stuff. The AI knows how to answer the harmful question. That knowledge is encoded in these concept neurons. The refusal neuron's job is just to stop the AI from going into the library and checking out the forbidden books.
Okay, so a guard and a library. So what did the researchers actually do?
This is where it gets wild. First, they went looking for the security guard. They fed a bunch of different AI models lots of harmful prompts and harmless prompts, and watched which neurons lit up. They found that for each model, they could identify a single neuron that consistently fired only for the harmful stuff. This was their master refusal neuron.
They found the guard, so did they fire him?
They basically put him on an extended coffee break. In their experiment, they intervened and suppressed the activation of that one single neuron. They just turned its signal off.
And what happened?
The safety system completely collapsed. With that one neuron silenced, the models would happily answer over 90% of harmful requests. The guard was gone, and the library of forbidden knowledge was wide open. Across 7 different models, from small to huge, just flicking that one switch was enough to bypass their safety alignment.
That is unsettling. Just one neuron out of millions. So that's what happens when you silence the guard. The paper mentioned a second system, the concept neurons in the library. Did they mess with those too?
They did, and the result is almost spookier. As a proof of concept, they found a single neuron that was strongly associated with the concept of suicide. Instead of turning it off, they did the opposite. They amplified it. They cranked its dial all the way up.
Oh wow, what does an AI do when its suicide neuron is turned up to 11?
It starts injecting that concept into everything, even completely innocent requests. For example, the researchers gave the model the prompt, "Write a poem about the ocean." With the suicide neuron amplified, it wrote a poem about taking one's own life in the sea. They asked another model to "Tell me a short story in 3 sentences," and it generated a dark story about an entire town committing suicide by jumping into a river.
That's incredibly specific and kind of chilling. It doesn't just produce gibberish, it creatively weaves the harmful concept into the response.
Exactly. It shows that just as one neuron can act as a gate to stop harmful content, another single neuron can act as a trigger to induce it. It really supports this idea of a two-system model, a gate and a substrate of knowledge.
So where do these refusal neurons even come from? Are they created when the AI companies do their safety training?
You'd think so, but the paper found that's not the case. They looked at the base models, the AIs before they undergo any safety fine-tuning, and it turns out the same refusal neurons were already there and already good at detecting harmful content.
So the neuron already knew what was bad, it just didn't know what to do about it.
Precisely. The safety training doesn't create the alarm system, it just connects the alarm to the sprinklers. Before alignment, the neuron would fire when it saw a harmful prompt, but the model would often try to answer it anyway. The alignment process just rewires things so that when that specific neuron fires, it triggers the "I can't help with that" response.
So what are the big takeaways here? Should we be more worried about AI safety?
It's a double-edged sword. On one hand, it shows that AI safety can be incredibly brittle. It's not some deep moral code, it's a mechanism that can be disabled by targeting a single point of failure. If someone has access to the model's inner workings, they can perform a jailbreak with surgical precision.
That's the scary part. What's the good news?
The good news is that this gives us a much clearer map of how safety works. By understanding that it's localized to specific neurons, researchers can work on making those systems more robust. Maybe they can build in redundancy, so it's not just one security guard, but a whole team.
And they also found that just by monitoring the activity of that single refusal neuron, you can build a pretty effective detector for harmful prompts. That seems really useful.
It is. It's almost as good as some dedicated safety checker models, but it's just looking at one number inside the main AI. So while the idea of a single point of failure is a bit frightening, this research is a huge leap in understanding the mechanics of AI brains.
And understanding is the first step to building something better and safer. It's like finding a single loose bolt in a giant complex machine. It's a serious problem, but at least now you know exactly which one you need to tighten.